What we call advanced building material is one of the strategic impact areas for development and R&D activities of Omya. Decarbonization is one of the important topics in the future of the built environment, driven by material scarcity and also by carbon capturing or climate issues. And that's also an area where the NEST and Empa is having a big research focus. So this overlap was almost a no-brainer then to start a collaboration.
The decarbonization of building materials is very important, since the building industry is accountable for roughly a third of the global CO2 emissions, which means it's one of the largest single contributors to climate change.
Omya has developed products that are extremely much more performing than anything that we find in the market, and they allow us to obtain a concrete that has got very low CO2 emissions because we're taking the cement out of it.
We are basically starting with a normal concrete recipe, so a mixture, and now the goal is to exchange some of the binder, which is the cement in this formulation, with our own materials. And then, of course, it's not just straightforward to do this, because you start also to change a lot of properties like workability or strength, or also durability properties.
We are managing somehow to get concrete with very good properties, what we would call a high performance concrete, with 30% of the cement, and the rest is substituted by limestone from Omya. Not only we take out of the cement, but if we do everything right, we have also a mixture that is much more stable, has got less shrinkage, less creep. The special aspect of this project is that we are going to implement it in an experimental building here at the Empa campus. It's called the NEST.
NEST is the building and innovation platform of Empa, which is the Swiss Federal Institute for Material and Technology Research. It provides a playground and innovation platform for companies and researchers in the construction industry to deploy and validate their new materials, construction technologies, processes, software.
Another project we have together with Empa and NEST is that we are trying to make earthen bricks, meaning that we form bricks that are usually used to make walls, but not in a traditional way, but just taking earth, so excavation material in the end. Add a little bit of a magnesium-based binder, which is also very low in CO2 footprint, or technically can even be CO2 negative. And then just use them as bricks, maybe for indoor walls.
We can substitute a bit of concrete with this material, and it basically looks like bricks, but they don't need to be fired at higher temperature, and they can just be used in buildings, especially in inside walls.
We want to cooperate with Omya because we have a vision, and that says we need to come to a point where construction actually becomes CO2 negative. A lot of this is associated with mineralic construction materials, concrete, asphalt of course, building bricks, things like this. And Omya is very strong in this field. The big picture really is that we want to fit into a construction industry that can react more agile, faster, respond to challenges quicker and in a more sustainable way.
Usually the development of products take much longer, maybe 5 to 10 years. And in this case, technically within 2 years we should have a structure that was made from a research project we were just working on recently.
So when we work with the academic world, most of the time what we are looking for is for expertise that we don't have. Expertise, but also capabilities, resources. You can see that here with Empa, they have the expertise and the equipment in concrete that we will never have. By being exposed and collaborating with the academic world, we get inspiration for our own innovation activities.
The collaboration that we have with Omya is one of the best ones that we have, because we are really developing ideas together.
It's a very collaborative spirit that we have, and it's great to work together with basically the best people in the respective fields.